We want to welcome you to this webinar. Today, we're very fortunate to have Dr. Joe Sobel. He's with AccuWeather, and he's going to be talking to us about forensic meteorology and just some meteorology in general. We're fortunate to have him, and he's available to speak to us. So, Dr. Sobel, if you will you start by just telling us, why are you doing what you do? How did you decide you wanted to do it?
Well, Pam, I didn't decide. I think it was decided for me, because as far back as I can remember, going back to 5, 6, 7 years old, I was always fascinated by the atmosphere, always looking for thunderstorms, always looking out the window to watch for the first snowflakes of a snowstorm, and being a weatherman or a weather forecaster, a meteorologist was something I always wanted to do, never wanted to do anything else. And so in that sense, I consider myself very, very lucky because I've been able to do for my career and for my living the thing that I always ever wanted to do.
Can you explain to us exactly what a forensic meteorologist is?
Well, meteorology, of course, is the science that deals with the phenomena of the atmosphere, anything that goes on in the atmosphere. Forensic, the definition of forensic means related to the use of science or technology in establishing facts so that it can be used as evidence in a court of law. And everybody, of course, is familiar with the forensic sciences these days, with CSI on television and all of those kinds of things. But most people don't realize the connection between meteorology and the forensic sciences. So our job as a forensic meteorologist is to go back through the historical weather records and to determine and to document what the weather was at a particular time and place in the past. And the reason that is of interest is if there is an accident of some kind, an automobile accident, a plane accident, or somebody slips and falls, and there is either a lack of information or a dispute, a disagreement about what the weather conditions were at the time of the accident, a forensic meteorologist could be called in to objectively and scientifically go back through the weather records and document what the weather conditions were at that particular time and place in the past.
Can you explain to us what your normal day is like?
Well, I in my career, I've been a broadcast meteorologist on radio and television, and I would do that most of the day. For most of my career, I got up at 2:30 in the morning and came to work by 3 o'clock, and I did radio and television broadcasting until mid to late morning. And then at that point, I would change my hat and put on my forensic meteorology hat and work on the projects that we had ongoing. A lot of the work that we do for attorneys and individuals and companies in which weather has played a role in a dispute that they might be engaged in. To give you an example of the kinds of cases that a forensic meteorologist is involved in, a typical slip and fall, where somebody slips, let's say, on some ice or some snow, and then the issue becomes, did the property owner have sufficient time to clear the ice and snow, and did they do that properly, or might they be negligent and therefore liable for the person's injuries? Damage caused by lightning or wind, how strong was the wind, heavy rain and flooding, automobile accidents, and of course aviation and marine accidents. We do get involved in some criminal cases. We've been involved in a number of murder cases in the past. And there was one case, Pam, that was very interesting, that it was a divorce case. And you might wonder, well, what would a forensic meteorologist have to do with a divorce case?
We were wondering that.
Yeah, or what could weather possibly have to do with a divorce? Well, this was a case where this couple was obviously not getting along very well, and one day she threw him out of the house. And not only did she throw him out of the house, but she took all of his stuff and piled it up on the back lawn, his clothing, his books, electronic equipment, all of his stuff, and put it out on the back lawn. And then it rained that night, and all of the stuff was damaged and destroyed. But the husband's attorney kind of didn't think everything was quite right there, so he called us up, and we went through the weather information. We look at the surface weather observations from nearby reporting stations. We look at radar, Doppler radar information. We look at satellite information, computer modeling, and whatever other sources of weather information that we can dig up. And we did that in that case. And as it turned out, it did not rain at all that night. The wife had literally taken the garden hose and hosed him by hosing down all of his stuff in the backyard and then claiming it had rained. So that's kind of an unusual case, but it gives you an idea that there are some weather connections in some cases that you wouldn't ordinarily expect there to be.
What about historically? Have you ever worked on any cases where you've gone back and looked at the conditions in like World War I or World War II for invasions historically?
No, we have not been involved in anything that goes quite that far back, but we have done a lot of reconstructions of weather situations and cases that have become nationally known. We were involved in some building collapses of sports stadiums, and like I said, some criminal cases as well. There was one murder case that we worked on back in the 70s in the Wilkes-Barre-Scranton area in Pennsylvania, in which a dentist was accused of murdering his wife. And the police were called in by the dentist on a Saturday morning, early on a Saturday morning, and indeed his wife was there and had been strangled. And the dentist claimed that an intruder grabbed a ladder from his garage, put it on the back of his house, climbed in, broke in. His wife heard the intruder, and she got up, and the intruder then strangled her, and the dentist got up, and the intruder hit him on the head and then fled the scene. So when the police arrived, they noticed that there were two cars in the driveway, and one car was covered by dew, and the other car was not. And the dentist had claimed that he and his wife had been in all night and they had not gone out. And when they saw the two cars in the driveway with differing amounts of dew, it made them a little suspicious. And so they called us in to determine whether or not that would have been a night that would have been conducive to the formation of dew. And another thing they noticed is that the ladder that had been taken from the garage and sitting on the side of the house, there was no water residue on the ladder at all, because it would have had to have been carried across the grass, across a lawn, and propped up against the side of the house. And they found no water residue on the ladder. They found no water residue on the windowsill or in the room that the intruder had allegedly broken into. So this, again, they wanted to know whether or not dew would have formed that night. And as it turned out, that was a night that would have been very conducive to the formation of dew. The relative humidity was very high. The night was clear, which allowed the temperature to drop to the point of condensation. There were very light winds, which was also conducive to the formation of dew. And this also was a location that was very close to the Susquehanna River, another source of moisture. So we were able to document that this was a night that the dew formation was very, very likely. And as it turned out, they were able to determine that the reason that the cars in the driveway were different was that, well, one, the wife's car, covered by dew, had been in the driveway all night, and therefore there was plenty of time for the car to cool and the dew to form. But the husband, the dentist's car, was warm and must have been driven overnight to keep the temperature up of the car and not allow dew to form. And then they were able to go out and place the dentist in various bars all around town and able to show that he indeed had been out partying that night, came home that night 2-3 o'clock in the morning, and his wife must have confronted him, and they got into a fight, and then he was the one that strangled her and not the intruder.
Wow.
So that, again, is another case where there's a weather connection where you would not really expect there to be, but sometimes there is.
Okay, so as we go through your slides presentation, and you start with basic principle number 1, would you walk us through that?
Two things to remember, not only just a forensic meteorologist, but a forensic scientist in general, is that we are not advocates. We are not there to take sides. Our job is to be objective scientists and to go back through the historical weather records to determine what the weather conditions were, not to be an advocate for one side or the other. Now, if the information that we have, of course, is compatible with one side's theory and the case that they're arguing, they're the ones that might want to use our information. But our job is not to be an advocate. Our job is to be an objective scientist and to determine the truth. And so that's principle number 1 for any forensic scientist. Our basic principle number 2 is to never stray from your area of expertise. And in our case, our area of expertise is meteorology. So, for instance, let's say a tree is blown down and unfortunately falls on a car or falls on a person and there's an injury or a fatality. We can go back through the historical weather records and determine what the wind conditions were at that time and place in question, how strong was the wind, what direction did the wind blow from, how common are those kinds of wind conditions, how frequent would the wind blow from one direction or another. Would a wind, or can a wind of 50 or 60 miles per hour do tree damage? We can answer those kinds of questions. But if I'm asked, Dr. Sobel, did the wind that day blow that tree down? I can't answer that question because that's not the purview of a meteorologist. I don't know what kind of tree it was. Was the tree diseased? Had it been trimmed recently? Those are areas of expertise for somebody else. I can give them the weather information, but only the weather information. And straying away from one's area of expertise as a forensic scientist are the kinds of things that can get you in trouble.
Okay. I mean, it makes me think now a whole lot about what I see on TV, and I do pretty much watch all the CSIs and all of that. So it puts a different light on things. So what about this Doppler reflectivity?
Well, a couple of the tools, one of the principal tools that we use in determining what historical weather conditions were is the Doppler Radar. we get weather observations that are taken from literally thousands of airport locations all across the country, and they give us terrific weather information. But as you know, weather conditions can vary considerably from one place to another that may be only a couple of miles away. So if we have an airport weather observation in one location, but the accident or the incident that we're concerned about happened 10 miles away, that weather observation may or may not be relevant to what the weather conditions were at the time and place in question. So one of the tools that's very helpful to fill in the holes between the weather stations is the Doppler radar. And we can see what happens on the radar between the weather stations. Maybe there was a tremendous storm at the weather station, but not at the site in question, or maybe vice versa. So the reflectivity represents the amount of energy that is returned to the radar set by the precipitation. And the radar operates kind of like a flashlight. It sends out a beam of energy. If the beam of energy encounters something to block it, and in this case it would be raindrops or, say, hailstones or a combination of them in a storm, in a cloud, then the radar energy is reflected back to the radar set, and we can measure that return and determine how intense the rainfall was, and of course where it's located. So that's the Doppler radar reflectivity tool is very important to us. Using various computer programs, the Doppler radar can then turn that reflectivity, that percent of energy that's reflected, back into an estimate of what the rainfall was. And we can get a visual and graphic mapping of what the total rainfall in a particular storm would be over a particular area. And that, of course, can help us determine how much rain fell at a particular site, even though it may be 5, 10, 15 miles away from an actual weather observing station. From Doppler radar, we can also get estimates of wind, which can be very helpful in determining whether or not there was wind strong enough to do damage, or whether there was any rotating wind, which might have been indicative of a tornado that had formed in that particular spot.
Wow.
So all of these things are used to predict the damage that will be caused by hurricanes?
Yes, absolutely. And we did a lot of work relative to Hurricane Katrina down along the Gulf Coast. And the big issue in Katrina was the property damage the result of wind, or was it the result of water? And we're going to have probably those same issues involved with Sandy in the New Jersey, New York area over the next couple of years. And so what we were able to do in Hurricane Katrina is by, again, using Doppler radar, using a very sophisticated computer model of storm surge, we were able to document specific and develop specific timelines of at any one particular spot, how the wind came up, when the wind peaked, and also simultaneously how the water rise at a particular spot came up and which peaked first, and then that information is turned around to an engineer, and the engineer can make some estimates of how much damage would have been caused by the wind and how much damage would have been caused by the water. And there were some particular instances in Katrina, and a couple of the slides, we were able to document the occurrence of a tornado embedded within the circulation of the hurricane. And one thing that was very strong evidence of that, if the wind in a particular spot is from one direction, a straight line, we call it a straight line wind, then the damage will all be blown down in one direction. But if there's a tornado and there's twist and rotation, one thing that you look for is the damage to be blown down in different directions. And if you see the two slides we have, it's very obvious that some of the trees are blown down in one direction and the other trees nearby are blown down in the other direction. And by comparing that to the Doppler radar, we were then able to document that in that particular spot, not only was there wind damage produced by the wind of the hurricane, but there was probably a small isolated tornado at that location as well.
Now, is this in respect to both of the slides?
Yes.
So both of those were done not only by the hurricane, but also by the tornado?
That's correct. Yep. You can see how some of the trees are bending to the right, have fallen down to the right, and others have been pushed down and are falling to the left.
Yes. Okay, now when you look at these things, is it an insurance-related problem that you determined whether it was water or wind that did the damage?
Yeah, what has transpired, what did transpire during Katrina and may also be happening with Sandy, is that insurance policies written by private insurance companies cover damage caused by wind, but they do not cover damage, flood damage. And the property owners evacuated. They came back to their homes and found just a concrete slab, and they turned in a claim to the insurance companies, and the insurance companies denied the claim because they said the damage to their home and their property was destroyed by flooding and the storm surge and not by the wind produced by the storm. Flood insurance is completely separate in most cases than wind insurance. And in fact, many private insurance companies these days do not even offer flood insurance. You have to get it through the government, through FEMA, and it can be very, very expensive. So the issue became what were the winds? When did the wind peak? Did the wind peak before the water? And then again, that information was turned over to an engineer, and it seems to be the way it's falling out is that the insurance companies are being held liable for the amount of damage the wind would have caused if there had been no water. And so, we turn our information over to an engineer, an architecture engineer or structural engineer, and then it's their job to try to determine how much damage would have been done by the wind that we're able to document.
We're looking at a slide now that has wind-water timeline. Can you explain this slide to us?
Well, that's an example of the product that we put together for Katrina, which shows the time on the axis from left to right, and then either the wind speed on the left-hand side, which we've noted in the purple, versus the height of the storm surge or the height of the water in the blue, and the legend for that is on the right. So by looking at that at this particular spot, you see that the wind speed reached over 120 miles per hour at this particular location before the water surge or the highest storm surge arrived, which would have been on the order of 20 feet. But that the wind peaked, in this case, a number of hours before the water reached its highest level. And those kinds of graphs and that kind of information was very important, again, in trying to determine what rights to compensation that property owners had.
And is this data collected from the Doppler?
A combination of everything. It's a combination of the surface wind observations that we were able to get from the Doppler Radar estimates, from aircraft observations, and also from the computer model, which modeled the storm surge and took into account the topography of the ocean floor and the topography of the shoreline as well.
Okay. Well, that tells us that says a great deal.
Absolutely.
Well, we just really want to thank you today for your input, for sharing with us, and I'm going to turn things over to Tracy.
Okie doke.
Thank you so much. That was a wonderful kind of insight into especially the forensic area, where we probably would have not have really realized all of that going on with different types of cases and areas. I want to remind our students that if they have, after they've listened to your recording and your presentation today, that if they have questions that they would like for us to get answered, if they will email me in the PowerPoint or presentation point of your presentation, there will be a slide there at the end. They'll have my information, and that students can then email me at tracy.clanton@ttu.edu. And then what I'll do is I'll pass on any questions that we get from our students in the club to you, Joe, and let you answer those. And then I'll pass those back out by our website and by email so that we can share that information with our students.
That would be terrific, and I should also add that any students that have an interest in weather, either forensic or just weather in general, to take a look at our website, AccuWeather.com. There's all kinds of weather stories and weather charts and maps and everything there that's updated every day, in fact, every hour. And so if any folks are interested in that kind of thing, that's a good place to look at.
Right, and what I'll do is I'll make sure that our students have your website as a link for a resource.
So that would be terrific.
That'll be presented in the area of resource links that we provide right alongside this presentation link, so that they can then take a look at your AccuWeather website and get a better idea of what you're talking about there and do a little bit further exploration. We really appreciate you joining us today, and we hope that you found this topic very interesting, and hopefully you'll explore it a little bit further on your own time. Thanks again for joining us today.